Good morning, good afternoon, or good evening, whatever the case may be. All right, continuing with our work for Unit 9, let's look at this information for the sine rule and the cosine rule. Let's focus on the cosine rule, right? The cosine rule is a simple formula based on the Pythagorean theorem. It allows you to solve a triangle in situations that the sine rule cannot. Once again, the sine rule is good for angle, angle, sine. It's good for angle, side, angle. It's also good for side-side angle, okay? However, the cosine rule will take care of the situations that are not listed here, and that would mean if I know all my sides, or I know two sides and the angle between the sides, right? So if I had a triangle and I knew the three sides, I could figure out everything else. Or if I had a triangle and I knew a particular angle, and I knew the two sides that form that angle, then I could solve. Okay? Now the formula is pretty straightforward. A squared plus b squared minus 2ab cosine c is equal to c squared, right? Where it's talking about the angle between the two sides. So you see the Pythagorean form, a squared plus b squared equals c squared, right? But there is a little extra bit. We're not going to worry right now on how the proof works. We're simply going to be focused on can we use it correctly, okay? And once again, c is the included angle between sides a and b. So let's go ahead and solve this. We're going to solve this triangle if the measure of angle C is 47 degrees. Right? So if this angle here is 47 degrees and A is equal to 15 and B is equal to 10, we're going to want to find everything else about the triangle. We're going to want to find the missing side, C, but we're also going to want to find what these other two angle measures are. We're going to want to find everything. So how are we going to do that? Let's set up our equation. So the first thing we do is we set up our equation. Right? Pretty straightforward. A squared plus b squared minus 2ab cosine c is equal to c squared. Next, let's put that in our calculator. So we enter the information into our calculator. 15 squared plus 10 squared minus 2 times 15 times 10 cosine of 47 degrees. Press enter, and we get that c squared is 120.4. Right, so we can write that down. C squared is 120.4. So therefore, C is going to be the square root of that. So let's go ahead, second square root of that answer. So C to a single decimal place, C is approximately 11.0 if I'm going to one decimal place, 10.97 if I'm going to two decimal places. So that is one part, right? That is not solving the triangle. Solving the triangle means finding everything. So now, how do I do the next step? Well, the next step actually refers us back to the law of sines, or also known as the sine rule, right? So what does that mean for us? What that means for us is that we can set up now this proportional relationship, right? That C over the sine of C is going to be the same as A over the sine of A, which is going to be the same as B over the sine of B. So here I have those numbers. All right, let's go ahead and solve for angle A first. So we set up our equation from this law of sines that the sine of A is going to be 15 sine 47 divided by 11.0. All right, we'll put that into our calculator. And we get what the sine of A is equal to, 0.997. And once again, make sure that you're in degree mode when you're doing this work. All right, so we have the 0.997. All right, so that's the sine of A, but we actually want A, so I'm going to take the inverse sine of that answer. And angle A is 85.8 degrees, approximately, if I'm going to one decimal place. Okay, and once again, this right over here was 0.9973. All right, so A is 85.8 degrees, right? So now what do I know? I know this unknown side and this angle. Well, if I know two angles, then clearly I know that third sine, and I know that, right, the measure of angle A plus the measure of angle B plus the measure of angle C is going to be 180 degrees. So therefore, the measure of angle B, right, is going to be, quickly set this up, 180 minus 85.8, oops, right, and minus 47. So angle B would be 47.2 degrees. Right? And hopefully that makes sense on the values, right? That C and B are very, very close, with C being a bit larger. And we see the similar piece in terms of our angles, right? So here's a law of cosines problem that if I ask to solve the triangle, in order to actually solve the triangle, I need to go back and also use the law of sines, okay? So once again, what do we have is that the cosine rule, right, allows you to solve these situations the sine rule cannot, but very typically you'll work with them together. Okay? So let's look at the cosine rule again. Here we have the next problem determining the value for h. Okay, what do I need to do? Well, I'm going to set up my equation. Okay, so I set up my equation, right? H squared is equal to 88 squared, 146 squared, minus 2, 8 times 88, 146, cosine of the angle between them. And now I just need to use my calculator. So I use my calculator, I put the value in, right? And it is good form to use the degree symbol. Now this value here, that's actually h squared. What I care about is the square root of that answer to find the length of h, right? And so that would give me to one decimal place 116.6, right? That we would say, hey, h squared is 13,595.8, and h thus would be 116.6. We don't have units here, so that would be my answer. Okay. Notice how I'm showing the work for every one of these problems. I'm showing the setup. I'm getting the work done. Some of you might be able to do this all in your head. There's lots of calculators online that'll calculate this directly for you. That's not what we're looking for. What we're looking for is how you're setting up the problem, how you're explaining your solutions. Okay? So our final example for the law of cosines before we, let you do some practice on your own is the next one. How do we find the value when all we know are the signs? So here we'll say determine the value for x. Well, let's set up our equation. So our equation, right, a squared, right, b squared, c squared, however you want to set this up. So 16 squared, a squared plus b squared minus 2ab cosine of the angle across from our unknown. So we go ahead and set this up and rearrange just a little bit to get. So we arrange to get 16 squared minus 8 squared minus 22 squared equals negative 352 cosine x. We subtracted 8 squared from both sides of the equation and went ahead and multiplied negative 2 times 8 times 22. Okay. What would be my next step now? Well, my next step, I might as well go ahead and simplify this a bit further, which is negative 292. And the step after that, divide both sides. And if we do that, here's what we're going to get. All right, we're going to have that negative 292 divided by negative 352, which gives us that value. But that's the cosine of x. We're trying to find x. So I'm going to take the inverse cosine of that answer, and there is my value for x in degrees, right? 33.9 degrees approximately. So the value for x is approximately 33.9 degrees. Okay, what does this tell us? This tells us that this angle here is 33.9 degrees. The angle over here is going to have to be smaller than that, which means that this angle over here is going to have to be obtuse. Okay, so if we were to be asked to solve this triangle, this would be a situation where I would know that my result for this situation here would be to have an obtuse angle, right? So if I had side angle, this one I know is going to be obtuse, okay? We're not going to worry about doing that here, but you will have that as one of the problems to solve in your practice set.